GWeasy. GWeasy is a software that is aimed to make gravitational wave analysis completely intuition-based. In the recent times, there is a lot of fascination with the field of gravitational wave and gravitational wave analysis. We have seen a lot of interest even within the non-scientific community thanks to the work done by the LIGO collaboration and films like Interstellar, where we saw more and more involvement of physics, especially higher energy astrophysics, in public communication and also in our science fiction. With that, within this year, we made major discoveries within the gravitational wave community, looking for black hole binaries that are millions of light years away and are of sizes that are only astronomical. With all of that, the main barrier right now in working with the gravitational wave analysis data, specifically for novices in the field, is really the initial IT skills that are required, and our goal with GWeasy is to completely remove that. So you might naturally ask, why GWeasy? What is wrong with the existing data pipelines? The existing data pipelines are mostly based in Python or C++ with a Python wrapper, and that means that you have to have at least a fundamental understanding of Python to work with any gravitational wave data. And even it starts even from fetching the data, although there are website-based approaches, but really if you want to work with like data that has a quantity at least a couple of minutes or hours in the time series, it becomes more and more clumsy when you try to access the data through the GWeasy website. So to work on anything related to gravitational wave data, you need to have a basic understanding of how to write in Python, how to save files in that path structure, and how to get the correct networking setup for fetching the data from multiple servers. Our goal with GWeasy is to completely remove that, and it started back a year ago when I was junior year student I'm doing my undergrad. And as a third year student, I really struggled with trying to set up the initial libraries and working with different versions of each of them. Which one would work on which Python version was also a struggle. Then a couple of libraries had conflicts with their requirements. So it was a long journey to be able to set up everything and then fetch the first time series data on my PC, and that kind of motivated me to make this process as smooth as possible. Right now I'm a senior year student doing my undergrad, and my goal is to make GWeasy so powerful that someone who is in the high school 8th grade, 9th grade should be able to work with gravitational wave data without having any prior knowledge about IT skills or programming. And it is my personal belief that to work with the astrophysics research grade data and to work with different pipelines, you shouldn't really have to have any software skills. That's not really what we are here for. And that's why GWeasy is completely interactive. GWeasy is GUI based. So all you have to do is click on buttons, put in the paths that you want. It will also let you select the paths via a GUI folder if you want. And all of this makes it much more easier for someone who does not have the coding skills, someone who does not have the experience working on different environments, someone who is not as proficient or does not even know how to work with Python. And with that, I want to increase the exposure of gravitational wave data and working with different, even time series based data using GWeasy. The main achievement of GWeasy coming in the next few months would be to have an encompassing compilation of all of the different gravitational wave libraries. Right now we have two successful additions. The first one is fetching gravitational wave data, the raw GWF files. We do this through two methods. The first one is the NDS server and the second one is the OSTF server. Both of them would give you the same data, but it matters a bit of where you prefer to get it from. Both of them are, of course, within Weasy completely interactive based. You just have to select them from a list. There's also an additional approach for members within the LIGO association, because you have to remember the NDS and OSDF servers are mostly based for public usage. So if someone who is within the association and wants to work with cluster machines that they might have that are affiliated with the LIGO collaboration, you also have an approach for that. You don't need to fetch to the servers. You'll get the data from your local machines. And with all of this in mind, our goal with Quizy is to set it up within universities, but to also promote it within high schools, so that more and more students who are not yet decisive about their field of research would be exposed to the fundamental physics of gravitational wave data and would be able to work on it from a very young age without any additional skills on the IT side. So that is Quizy. Now that we know what GWeasy is, what are the next upcoming updates from the GWeasy project? Currently, we have full support for Linux and Windows systems for running GWeasy without having any prior installation setup. And we are in testing phase for our Mac version, which should hopefully come out in the upcoming weeks. With that being done, we also plan to make GWeasy available through a website. So we would be hosting the GWeasy software on a server, and you can run it through a web interface even on your mobile phone. With all of the different pipelines being integrated, with all the different OSs being supported, with even also different devices being supported. Our next goal is to take it further and to introduce an introduction-based course series. With this course series, we are going to invite multiple experts in the field of gravitational wave community to come and teach different people at different career stages. Our starting goal is with high school students, because those are our bright future and those are the people that we can influence the most. Show them what the scope of research is in this field. And also, I think that the more and more people we introduce to the field, the greater discoveries we'll get. With that, we'll also have a series that would be for students who are in college but not yet working in the domain of astrophysics or even physics. I myself am a student of electrical and computer engineering, but I had a great fascination with high energy astrophysics, and that is what motivated me to dive deep into this field independently. And I'm really happy that I did, because I'm really fascinated by the nature of gravitational waves, general relativity, black holes, and neutron stars. With that being said, we also plan to make it a little bit less conventional based teaching, and we tend to add multiple gamification modules within the website of GWeasy, so that we can make it a little bit more easier to also not only work with gravitational wave data but understand what you are working with. And that is very important as far as I think, because it is not only really intuitive if we just provide you with the tools of working with something. You also have to provide you with the resources of understanding what you're working with. And with that, I think the next steps in terms of GWeasy would be this multiple gamification modules that would, for example, teach you how Michelson's interferometer works, or would teach you how the gravitational waves propagate through the vacuum of space, or maybe even also how you can hear them. That might be something you might be interested in. With all of these different modules, different features, addition of the different pipelines, we aim that the current interest in the community of gravitational wave physics would grow by at least a few times, if not more. And with the current rate of discoveries, I think it would enable us to increase the awareness of this field, to increase people's understanding of the universe, and to improve the access to the universe. With that, keep exploring, keep using Wheezy, and we'll see you soon.